Hello everyone. Today we're looking at the problem maximize active section with trade 1, which was question 2 in Biweekly contest 153. So the question reads that we're given a binary string s of length n, where 1 represents an active section and 0 represents an inactive section. You can perform at most one trade to maximize the number of active sections in S. So the way a trade works is that first, we convert a contiguous block of ones that's surrounded by zeros to all zeros. Then afterwards, we could take a contiguous block of zeros surrounded by ones and make them all ones. It's a little confusing, but when we get into an example, you'll see how this works. So what we want to do is return the maximum number of active sections in S after making the optimal trade. So one interesting thing here is this note at the end. I think a lot of people may have skipped over this, but the note here says we want to treat S as if it is augmented with a 1 at both ends. So really the string that we should be working with looks like this. So we would take a 1 in the beginning, put S in the middle, and then a 1 at the end. But these 1s will not contribute to our final count, and you'll see how we handle this in the problem. So looking at the example 0, 1, 0, 0, we're going to output 4. The explanation is that first we take that string and we augment it, like shown on our note. So we're going to add a 1 to the beginning and the end. Then what we do is we're going to choose the 0, 1, 0, 0 string. So this 0, 1, 0, 0, we do the trade on it. So first we convert the entire thing to zeros. And then what happens is we're going to take this block of zeros as the second part of our trade and convert it all to ones. So you'll see now that the final string without the augmentation is 1, 1, 1, 1, which is a length of 4. So let's think about what actually happens when we do a trade. So we know that to do a trade, we have to find a section of ones that are surrounded by zeros as the first step. So let's do that here. So what if we find these ones and we see it's surrounded by these two blocks of zeros? So let's say we want to do the trade on this section. So what actually happens here? So what would happen is that we want to take all these ones and convert them to zeros. So after this, our string would look like this. So what we've done here is we've taken these ones that are in between these zeros and we've converted them to zeros itself. So now really what we see is that this entire section, ending here and starting here, has become all zeros. And we can see those lines drawn here, right? So that's the first step. We're going to find the section we want to do a trade on, take the ones and convert them to zeros. But then there's a 1 here, right? Because we're augmenting this string. So what's really going to happen is that this section is also between two ones, right? So we could also convert this entire section now into ones. Right, so you'll see the final result here is that if we did the trade on this section, what actually happens is that these two ones remain the same. Really what we're doing is converting the outside zeros to ones. So we can simplify this down a little bit and say, we don't have to do this two-step process. What we can really think about is that if we see an area that matches our conditions, right? We see ones surrounded by zeros. What we're really doing is taking all these zeros here and just changing them to ones, and that will be our final result. So we could think about this when we're solving the problem. Instead of having to do this kind of complex two-step trade, what we really think about is when we find a section that is valid and we can do the trade on, we could think about just converting these outside zeros to ones to get our count. And we can do the same exercise with the next section. So we find this block of ones surrounded by zeros, right? So we have these zeros over here and these over here. And remember, there's also a 1 over here. So we're looking at this block right now. So we could do the same thing, convert them all to 0 first. And you'll see we've gone from 1, 2, 3, 4, 5, 6, 7, 8 characters with a 1 to 8 zeros here. And remember, there's a 1 here and a 1 here. So now we can convert all of these to ones. So you'll see again, what we've really done is we left this 1 the same, but these outside zeros we've converted to ones. So again, what we're doing here is we're just finding the zeros that surround that section of ones, and we're converting all of those to ones. So I think simplifying it in your mind this way makes it a little easier to solve this problem. So let's look at a real example and see how we would actually solve it. So here we're looking at the example 1, 0, 0, 0, 1, 0, 0, 0. So the first thing we want to do is augment our string. So let's do that. We're going to place a 1 in the beginning and then just write our string. So we have 1, 0, 0, 0, 1, 0, 0, 0, and then put a 1 at the end. So this will be our augmented string. So what we want to do in this problem is deal with groups, right? We want to find a group of 1s surrounded on both sides by groups of 0s. So what we should do is let's iterate through our string and figure out what those groups are. And how we can do that is just starting our index here, and we're going to go through. While we see the same character consecutively, we'll just increase our count. But when we change characters, we'll take the count that we've had, we'll put it into an array, and then we'll basically reset our count. So you'll see what that looks like. So I'm going to iterate through until I get to 0. So at this point, what I want to do is I'm going to place into an array and say I have found 2 1s. And notice I'm placing both the count as well as the actual element that I am looking at, so I can keep track of what I'm seeing. So again, we'd iterate through till we get to this next one. And then here, I've seen 3 zeros. So I can place 3, and then I could put 0 here. Then I'll come to this 0, and here I've only seen 1. So it's not really a grouping, but still we should consider it. And then I'm going to come to this 1 here. I will say that I saw 3 zeros. And then at the end, finally, when I get to the end of my string, whatever I have left, I'm going to put in. So again, I'll put that I have 1, 1. So now I have this array, which represents all the groups that I have in this string. So how do I actually use this? So remember that what we're looking for is a group of 1s surrounded by 2 groups of 0s. So we can't do anything with this, right? Because this is not surrounded by 0s. There are no 0s on the left side. So we can move over to here. This is not a group of 1s, so let's move past. So here at index 2, we see that this satisfies our condition, right? So we have a group of 0s on this side and a group of 0s on this side. And what we know is that really what we're doing, what we can do for this is we could take these and convert them to 1s. So we're basically taking these sections and making them 1. So what we can do is if we know the count of the ones that I already have, I can basically just add these in. So let's say in my original string, I had 1 1 here, or 2 1s rather. I had these 2. Well, now I know that I'm converting these 2 sections of 3. So I could say, is 2 plus that 6 greater? So you'll see what I'm getting at. Basically, what I'm doing is I'm going to take the original amount of 1s that I had, and then each time that I find a section that I could do a trade on, I'm going to see if doing this trade gives me a greater value. And in this case, it does, right? Because I'm taking these 2 original 1s, but I'm also adding these 2 sections in. So I can record this and say that my max so far is 8, right? And then I would move on. So then I could come here. This does not meet my criteria because it's not a 1, so then I'll move here. I do have a 1, but you'll see that it's not surrounded on this side by 0, so I can't do anything here. And then finally, I've reached the end of the problem. So just to reiterate what we're doing in this problem, basically we're going to go through and we're going to find all these groupings of 1s and 0s. Then, if we find a group of 1s surrounded by a group of 0s, we know that we can use this and make a trade on it. So we can simulate what would happen if we made the trade. We know we'd be adding these 2 sections in and just see what our maximum score would be. So we can basically iterate through our entire grouping array, look for all the places where we can do a trade, and see what the maximum score that we would get if we made that trade. So the time complexity here will be O of n, because we have to iterate through our string 1 time in order to actually get these groupings. And then in the worst case, iterating through the groupings can be O of n. So say, for example, we had a string like this, where each individual element would be its own group. So potentially we'd have to go through each element again. So it's going to be O of 2n, but we can simplify this down to just O of n. Let's hop over to the code and see exactly how this works. So the first thing I do here is get a count of all the ones that are in my string already. So this is kind of going to be my base, right? I know that I at least will have this many active sections, so I'll start with this. And potentially, if I make a trade, I can get more. So I'll have this as my current active as I start the problem. Then I set up my groups array, and then I'm going to augment my string by placing ones around it. So I know that the first character that I'm going to be looking at is a 1, because I just augmented my string and put a 1 in front. So I'm going to start with that my current character is a 1, and there are 0 of them so far. So we're going to have this for loop, and then I'm going to iterate through my string. So if what I'm looking at does not equal current, this means that I'm basically going from a 0 to a 1 or a 1 to a 0. So what I'm going to do here is I'm going to add what I've seen in my current group, and then I'm going to update my current. Because if I'm going from 1 to 0, I need to now keep track that I have a different current character I'm looking at. And I'm going to set this count equal to 1. Otherwise, that means I'm seeing the same character, so I just increase my count and keep going. Then at the end, I haven't recorded my current group yet, so I'm going to put that into the array. Then here's the logic where we actually look through the groups that we found. So my current max group is going to be 0. So what I'm going to do is I'm going to start at index 2 for the groups. And why do I start at index 2? Well, I'm looking at groups of 3, right? So if I'm looking at groups of 3, I know that my first group is going to go 0, 1, 2 in terms of indices. So I'm going to start at index 2 and work backwards. So you see that I'm looking at index 0 by doing I minus 2, and then also looking at my group I. So I'll say that again. Since we're looking at groups of 3, we know the first group has to end at index 2. So I'm going to start at index 2 and just kind of go backwards. So this case I'm looking at, if my current group 2 is 0 and the group minus 2 is 0, right? So basically what I'm checking is that if my surrounding groups are both 0 groups, then I know that the middle one has to be a 1 group. So this is a valid case where I can do a trade. So what I'm going to do is I'm going to record what I've seen so far. So I'm going to say the max grouping that I've seen so far has been whatever I found already, or the number of zeros in these two surrounding groups. So I'm going to record the number of zeros in the group I minus 2, and then also group I. Then finally, the end, what I'm going to do is return the max of the max active, and this is what I saw in the beginning, or the maximum of the max active plus the maximum group that I have found. So the maximum number of zeros that I can change. So let's submit and see if this works. And it does work. Hopefully this is helpful and it made sense. If you liked the video, please like and subscribe, and thank you for watching.